Hello again. Today we're going to talk about the chemical bonding. So when we talk about chemistry, we're talking about elements, atoms, how they're put together. We also want to talk about how different atoms or elements join together to form bigger structures. So for example, how hydrogen and oxygen would bind. What kind of bond is that? How would carbon and hydrogen bond? What kind of bond is that? And bonds are important because that's the way things are held together. And when you put something together, you can store energy that way. And when you break a bond, you can release energy. And so later on, we're going to talk about a form of energy that we use called ATP, and it's all about breaking and making bonds. We also want to understand about bonding because that's what holds us together. When we make proteins, we're linking things called amino acids together. We're bonding them together. When we make big sugars called polysaccharides, we're bonding, we're connecting sugars and putting those together. So we're going to cover a couple of types of chemical bonding today, and then we'll move on to do a little more chemistry in the next video. So when we talk about chemical bonding, there are three types. You have ionic bonds, covalent bonds, and hydrogen bonds. These two are your stronger bonds. Hydrogen bonds are the weakest of the three types of bonding. Okay, so covalent and ionic bonds are stronger than hydrogen bonds. So the first type of bond we're going to talk about is an ionic bond. And usually when you think of an ion, you kind of think about a charge, maybe positive or minus. So kind of keep that in mind as maybe a clue about an ionic bond. And an ionic bond is made by transferring an electron from one atom to another. So here we have the sodium atom and here we have the chlorine atom. And if you remember from the first talk we talked about chemistry and how they're set up, you have a nucleus with your protons and neutrons, and then your electrons are kind of around that nucleus. Well, sodium has 11 protons and 11 electrons, so it has the same number of positives as negatives, so it's neutral, has a neutral charge. Chlorine has 17 protons and 17 electrons, so the number of positives and negatives are equal, so it's neutral charge. When you make an ionic bond, when you join sodium and chlorine together and make sodium chloride, which is a salt, you do that by transferring one electron from sodium to chlorine. And so you have this loss of electron from sodium and this gain of electron by chlorine. So now, because you've lost one of your electrons, you have more positives, more protons than you do have electrons. So now this atom is positive. It's an ionic, it has an ionic charge to it. Chlorine, now because it has gained an electron, it is now more negative. It has more negatives than it does positives. So it makes it negative. So think about positive and negatives, opposites attract. So now that this is a positive atom and this is a negative atom, these two will bond together. And that's an ionic bond when you transfer an electron from one element or one atom to another. Now an example of this, again, is sodium chloride. So these are your sodiums, these little yellow things, and chlorine. And when they join together, you make salt. And many times the ionic compounds, they form things that look like crystals. Okay, so sodium chloride is an example of an ionic bond, and you get the sodium chloride or salt crystals. So it's a strong bond. It's hard to break down salt. All right, the next type of bond is a covalent bond. And a covalent bond, instead of transferring your electron, you share it. Okay, so you're sharing electrons. So here we have 4 hydrogen atoms and a carbon atom. And here we have formed what's called methane gas, CH4. Methane gas is a byproduct. Think about cows when they eat and when they expel their gases, that's methane gas. Or byproducts of like a garbage dump. A lot of times methane gas is produced as a matter of the digestion and the breakdown, the rotting that's going on inside the garbage dump. So the way you make methane, you add hydrogen to carbon and you share electrons. So you can see here's carbon and you have these 4 electrons out in this outer orbit and you have 1 electron on each of the hydrogens. Well, these hydrogens and carbon electrons join together, okay, and you get these electron pairs where you're sharing that electron here. Okay, so that makes a covalent bond. Again, it's a fairly strong bond as well. So ionic bonds and covalent bonds are both strong bonds. Now, and some other examples of some covalent bonds. This is carbon dioxide, CO2. Carbon dioxide is the gas when you breathe out. That's the gas that you're breathing out. Carbon monoxide, CO, not to be confused with carbon dioxide. This is what you get when you burn gas or fire, kind of a combustible byproduct. This is the one that you don't want to be exposed to because it can kill you. But CO2, carbon dioxide, is a natural byproduct of respiration. And if you notice in this particular picture, you'll see here's oxygen, here is the carbon, and here's the other oxygen, and they line up, and there's no polarity. Okay, so there's no charge on this molecule. It's neutral. It's a neutral molecule, and we call this a non-polar covalent molecule. Now, water is also a covalent molecule. It's formed using covalent bonding, that electron sharing between one oxygen and two hydrogens. Now, when oxygen and hydrogen come together and form a water molecule, H2O, it is polar. There is a slightly positive end to water, so that the oxygen end is slightly negative and the hydrogen end is slightly positive. So that gives it polarity. So think about the North and the South Pole, two different ends. So in the water molecule, there's a negative end and a positive end. So these are two examples of covalent bonds. They can either be nonpolar or polar. Now the third type of bond is called a hydrogen bond. Okay, so hydrogen bonds occur between polar water molecules. There's other forms of hydrogen bonding, but one example is in water. And so here you have a water molecule and a water molecule and a water molecule and a water molecule and a water molecule. And remember, the oxygen end of the water is negative and the hydrogen end is positive. Well, those attract each other. So positives and negatives attract each other. So you get this hydrogen bonding. So I'm going to take just a short break and let you watch a quick video, and then I'll come back on the other side.
The atoms that make up a water molecule are in a constant tug-of-war over their shared electrons. Oxygen exerts a far stronger pull on the shared electrons than does hydrogen, and so the electrons spend more of their time closer to the oxygen atom. Because of this unequal sharing of electrons, the oxygen atom in a water molecule actually has a slight negative charge, and each hydrogen atom has a slight positive charge, even though the water molecule as a whole is neutral. Because of the unequal sharing of electrons and the resulting positive and negative poles, a water molecule is said to be polar. The polarity of water molecules causes them to be attracted to each other. Since the positively charged atom involved in this special type of attraction is always a hydrogen atom, this kind of bond between molecules is called a hydrogen bond. Each water molecule can hydrogen bond to 4 other water molecules. A hydrogen bond is weak and lasts only a tiny fraction of a second, but it takes a lot of energy to overcome the combined attraction of many hydrogen bonds. This explains water's great capacity to store heat, its high boiling point, surface tension, and several other unusual properties.
Okay, so hopefully you learned a little bit more about hydrogen bonding from that video. And so I just wanted to show you that even though they're not the strongest bonds, they do have some strength. When you think about surface tension of water, so imagine if you put your hand on water and you kind of pull your hand away and the water kind of sticks to it before it breaks, that's the surface tension. And that surface tension is actually strong enough for some bugs to even walk across the water. So those hydrogen bonds, although not really strong, they do allow us to have surface tension of water, so it does have some strength. So that's all I'm going to talk about today on the chemical bonding. We'll talk about bonds some more as we move through some more chemistry, and I will see you in the next video. Thank you for your attention.